Hello, everyone. Welcome to my second video attached to my article entitled Estimating Diet Level Processes in MFT Research, General Overview of the Common Fate Model and Extensions into Mediation, Moderation, Growth, and Hybrid Models. Again, my name is Michael Fitzgerald, the author of the article, and in this specific video, we will be talking about and walking through the Common Fate Mediation Model. So first, let's take a look at a figure of the model that we will be estimating. So this is the model that we will be estimating. So we will specifically be looking at mediation, or the test of indirect effects, when all of the constructs are common fate latent variables. So we are essentially assessing mediation at the dyad level. And so in our model, we are going to be testing relationship mindfulness as our independent variable, dyadic coping as our mediator, and relationship quality as our dependent variable. And then we are going to, again, estimate all of these residual covariances and test those indirect effects using robust maximum likelihood. And then we'll also provide and talk through testing mediation with bootstrapping. So let's take a dive into M+. So here is our M+ input file. And so for those of you who may not be familiar with M+, I go over the basics of M+ in the first video. And so we are actually going to jump straight down into the use variables command. All right, so here we are going to be using 6 total variables. So we're going to use male and female reports of dyadic coping, of relationship quality, and of relationship mindfulness. All right. We have missing data, and we have our dyad ID variable to specify our couples. And then we are going to be using, again, robust maximum likelihood with Yuan and Bentler corrections, also called a scaling correction factor, to address non-normality in our residuals. If you are interested in bootstrapping, which is the most common approach to estimating indirect effects, you would take off the R in estimator, and in fact, you wouldn't even need this line, and then you would just comment in bootstrap, and then you'd specify the number of bootstrap samples that you would want. And typically, this is going to be 5,000. But bootstrapping can take a little while. Sometimes it takes as little as 30 seconds, but for more complex models, it can take several minutes depending on the power of your computer. So for ease of demonstration, we are going to be using robust maximum likelihood. So in the measurement model, it looks very, very similar to what we had in the baseline common fate model. And so we have our latent variable that we are creating, and we are going to name dyad cope. This is going to be the common dyadic coping subscale. And we're going to fix those loadings for the female and male reports to both be 1. And we're going to do the exact same thing for relationship quality and for relationship mindfulness. So each of these 3 scales have relationship referential items. So they're all referencing the relationship, not my perceptions of my partner or my partner's perceptions of me, but we have a common reference point, which is the relationship. Right? And so we're accounting for shared variance in the between the dyad members, between the male partner and the female partner. And then we're going to have a structural portion of the model. So this is going to consist of our direct effects. So remember, an M+ by is factor loading. On is going to be our direct effects, our regression. So we can have as many variables to the left and to the right of our on statement as we want. So we only have kind of one true dependent variable, and that's going to be relationship quality. And that is going to be predicted by relationship mindfulness, which is our independent variable, and dyadic coping, which is our mediating variable. Then we also need to specify the path from our independent variable to our mediator, and that is this second line. Okay, so we have mediator on our independent variable. So next we have our covariances. So because we are accounting for the interdependence through the common fate latent constructs, we might also have within-person effects that are not accounted for by that shared variance. There might be individual factors that might be inducing an association between each of the observed variables across within a dyad member. Right. So, for example, a male's level of neuroticism might inform how they evaluate each of the items on the relationship mindfulness scale, the relationship quality scale, and the dyadic coping scale. And that might induce or cause a residual correlation between them because of that unmeasured factor. So that is what we are parceling out in this analysis. We want to account for those within-person effects. So our direct effects and our indirect effects are unbiased because we run a high risk, depending on the magnitude of these residual correlations, of having fairly biased results when we don't include those covariances. Okay. So in the output, we are going to request SAMSTAT, which is our descriptive univariate and bivariate descriptive statistics. We have our residual variance covariance matrix. We have Tech 1, which labels our parameters in case we get an error message. Tech 4 is our variance covariance matrices. STDYX gives us standardized estimates. So STD means standardize, and then Y and X indicate your independent and your dependent variable. Mod indices will provide us with, since we have an over-identified model, we have a positive number of degrees of freedom, whether or not our model is misspecified to some extent, and it will give us possible solutions if there is a misspecification. And then we finally will request C interval. And this will give us our 95% confidence interval. If you were bootstrapping, then you would add in this bootstrap in the parentheses, and that will give you bootstrapped confidence intervals that are asymmetric. Whereas in this model with robust maximum likelihood, we are just going to get symmetric confidence intervals. And so one thing that we will do is estimate those indirect effects. And so what we will do is we'll do model indirect, and this is a nice way, fancy way, or shorthand, I should say, way of estimating indirect effects in M+. And so what we will do is we will just have our dependent variable, our CSI, and then do IND, and then relationship mindfulness, and M+ will automatically estimate every possible indirect effect between these two variables. Right? So if you're familiar with Lavande, you have to manually estimate every single indirect effect, but in M+, you only have to estimate, specify the indirect effects from the IV to the DV and all of the mediators, whether a single mediator or a double mediator, a serial mediator model, M+ will automatically estimate all of them. Right? You can also manually specify them using the model constraint command, but that is a little bit more cumbersome and gives you the exact same results and is really only used when you're testing moderated mediation. Right? So we can go ahead and we can run this. So we'll take a scroll down. Again, if you want more of an explanation of what some of this early sample statistics are, check out the first video where I go over the baseline common fate model, and I go into more depth on these, on all of these bivariate and univariate statistics. So we will scroll down and we will take a look at our model fit. So our model terminated normally, which means that we actually can interpret our results. Right? So we have a correctly specified model and didn't run into any convergence or estimation errors. So we have our chi-square test, which is non-significant. Again, typically this is a very sensitive test. So even though it's non-significant, we can actually say with a decent amount of confidence that our model is fitting our data really, really well, which is what we want. We have our RMSEA, our CFI, our TLI. These are commonly used global fit indices, both absolute and relative, commonly used in structural equation modeling. And then we also have our SRMR. right? So all indications from our model data fit indicates that we have a good fitting model. We want these values to be above 0.95. In general, on average, we want this value to be 0.05, 0.06, perhaps 0.08 or below. But what we do find is that the RMSEA is biased in models with very small degrees of freedom. And so we don't place a whole lot of weight on this statistic when we have only 3 degrees of freedom. The RMSEA is generally more accurate when you have 15 or more degrees of freedom, sometimes even 20. So we won't place as much weight on this fit statistic, but our CFI and our TLI are looking very good. We will scroll down, first see our unstandardized results, but then we'll scroll down to our standardized results because we want to, again, check those factor loadings to be sure that they're above the kind of the prerequisite kind of 0.70 level to indicate, the effective use of a common fate model. Because if those loadings are lower, then maybe another dyadic model is more appropriate. So we look here and all of our loadings are above that 0.70 threshold. So that means the variance that is shared between dyad members is substantial. And again, this provides some evidence that we are using the appropriate model. So let's look at our standardized output, our standardized regression coefficients. So we have our dependent variable first, and then that's being regressed on our independent variable, and that C prime path is not significant. So the association between our IV and our DV is only 0.046, and it's not significantly different from 0. And we have our effect of the mediator on our dependent variable, where a 1 standard deviation unit increase in dyadic coping is associated with a 0.78 standard deviation unit increase in relationship quality. So how I would interpret this is, when couples are able to cope with stress together, on average, the couple on average is also happier. So again, in the interpretation, you will see couple being used very, very intentionally to indicate that we are interpreting the associations at the dyad level, because that is the objective of the common fate mediation model. All right. We also have our residual covariances. And again, we might want to take a peek at these just to get a sense of how much of a residual covariance is there. But these are not necessarily things that we are overly interested, at least at this point. In the multi-level common fate model, these residual correlations and covariances, they become of much greater interest and theoretically meaningful. Here, they are not all that theoretically meaningful. And we'll scroll down just a little bit more and we will get our estimates of explained variance. All right. So that means relationship mindfulness is accounting for approximately 25% of the variance in dyadic coping. And the joint contributions of relationship mindfulness and dyadic coping is accounting for 64.3% of the variance in relationship quality. Right? So if you would like to, again, explore the residual matrix, the Tech1, the Tech4, the mod indices output, I would recommend, again, going back to that first video where I demonstrate the baseline common fate model, and I go much more in depth into what those pieces of output give you. But for here, we will actually finish up. This is the common fate mediation model. Again, hopefully this video has been helpful in helping you understand and learn the syntax for estimating the common fate mediation model. And hopefully, again, it's been informative, and see you in another video.